Forests across the eastern U.S. are changing. Once dominated by oak and hickory, these landscapes are increasingly filled with less fire-adapted species like red maple. Fire exclusion has allowed these mesophytic species to thrive, altering both forest structure and function. This process, called mesophication, occurs when fire-intolerant, shade-loving species outcompete fire-adapted species. Over time, they create cooler, shadier, and more moisture-rich conditions, which further suppress fire and reinforces the dominance of trees like red maple. So, some of y'all, like me, have probably scratched your head at the word mesophication. And on the other hand, some of y'all have already probably figured out that mesophication comes from the root word mesic, and that refers to a habitat that has a moderate amount of moisture. So, the exclusion of fire has allowed mesophytic species to thrive, altering the composition of these ecosystems. So in today's video, we're going to explore how fire exclusion has reshaped our landscapes and what management strategies are needed to restore the balance in our Appalachian forests. To understand how fire exclusion has reshaped our forest, it's important to first look at how fire-adapted species like oak and hickory relied on fire to thrive. Oaks and hickories thrive in fire-maintained ecosystems. Oak leaves, with their thick and curled structure, dry out quickly, promoting the spread of fire. This allows for the clearing of the forest floor and creates ideal conditions for oak regeneration. Another cool fire-resistant trait of an oak is the bark, which provides thick insulation and protects the tree's vital tissues from the heat, which allows them to withstand low-intensity fires, which is seen here. Along with oaks, hickories, though they're less fire tolerant, possess deep root systems that allow them to resprout after being top killed by fire. So, this ability, along with their thicker bark, helps hickories persist in fire adapted landscapes alongside oaks. In contrast, mesophytic species like red maple produce moisture retaining leaf litter, suppressing fire and preventing oak regeneration. Without fire, oak-hickory systems struggle to maintain dominance as mesophytic species outcompete them for light and resources. So I just mentioned that mesophytic species can outcompete oak and hickory. But how does this happen? So let's take a closer look. Seen here is the Nowacki and Abrams 2008 publication in Bioscience that illustrates the mesophication process and the shifting dominance of forest species over time. Looking at the right hand of the chart, you can see that in the pre-1900s, there were frequent fires that kept the forest open and it was dominated by oak and hickory. Then, in the mid-1900s, fire suppression begins, leading to increased shade and the establishment of these mesophytic species. In the early 2000s, there were dense mesophytic dominated forests that become prevalent, reducing fire intensity and frequency. Looking at the left of this graphic, you will see what's known as a positive feedback loop of mesophication. It's positive because this means the process reinforces itself, which can lead to amplification or acceleration of this initial change. Looking at the beginning of this feedback loop is your mesophyte establishment. And in this example, you'll see the mesophytic establishment of red maple and poplar. The second part of this feedback loop is your mesophyte leaf litter, which has high moisture holding capacity and low flammability. And that leads into the lack of fire effects, meaning if a fire were to burn, it would be low in intensity, or fire may not be able to burn at all. This whole graphic together shows that mesophytes' development of cool, moist understories prevent fire from clearing the forest floor. So this creates a feedback loop, making it even harder for fire-adapted species like oaks and hickories to regenerate. But there is hope. Through active management and restoration strategies, forest managers can break this cycle. Prescribed burns, thinning, and other techniques are being employed to reintroduce fire-adapted species into these altered ecosystems. Prescribed fire is a key tool for restoring fire-adapted forests. It clears out the dense undergrowth, reducing competition and promoting the regeneration of oak and hickory seedlings. But prescribed fire alone isn't always enough. Forests that have been dominated by mesophytic species for too long often need additional treatments. So this is where mechanical thinning will come into play. So to reduce mesophytic species and create conditions where fire can do its job, forest managers also use mechanical thinning. So this means they remove dense patches of mesophytes, whether it's red maples, beeches, poplars, and this allows more sunlight to reach the forest floor. Along with thinning, there's a similar practice known as canopy gap creation, and this involves the selective removal of small clusters of trees or individuals to create openings or gaps in the canopy. And so the purpose of this is really it focuses on increasing sunlight penetration to help light demanding species like oak and hickory to regenerate, but this is usually used in a localized targeted area. So think of thinning as a broader removal of trees, while canopy gap creation is more targeted for an area. Before wrapping this video up, here are some key takeaways that I hope you've understood. Our forests have undergone significant changes due to fire exclusion, and this has led to the rise of our mesophytic species and to the decline of our fire-adapted ecosystems. The second takeaway is the importance of prescribed fire in maintaining our fire-adapted ecosystems. The third takeaway is understanding that positive feedback loop of mesophication and why that allows mesophytic species to dominate and makes it hard for hickories and oaks to regenerate in that type of ecosystem. And lastly, together, thinning, canopy gap creation, and prescribed fire can restore the fire regime that once maintained these ecosystems, helping to bring back the balance between oak, hickory, and mesophytic species.